Hello, in this video, I'll be giving a general introduction to using the Wolfram Cloud Mathematica, and this will just be the basics for any calculus or differential equations or linear algebra course. So you want to go to wolframcloud.com, and generally you'll have to log in and create an account. It should be free, and once you do that, you should see the screen. At this point, you can open up your old notebooks or you can start a new notebook. If you have other notebooks, what happens is you can save them. When you create a notebook, you can save them and then you can access them. On top, you do have the Wolfram documentation, which gives you access to all of the core language of Wolfram. You do have fast introduction to Wolfram language for math students, which I recommend checking out. You do have access to your cloud files over here, and you can also look up any topics that you need to do that, or you can just Google them as well. So let me close this out and open a notebook. So it's a little non-user friendly at the beginning, but you'll get used to it. So basically what happens is when we enter any mathematical command like 1 + 3, in order to evaluate that, we need to hold the shift key and hit enter. As you can see, Wolfram, first of all, numerically identifies the line that you have entered the command. In this case, I just asked it to add 1 + 3, and it occurred in input line 1, and then it has outputted in line based on the input 1, it has outputted 4, and it has stored it in this in the first output. By the way, the first output is accessible by typing %1, and as you can see, it has stored this value into this variable. Okay, so that's not the typical mathematics symbol for %. It's rather a way of accessing the first output. You can erase this by going to the right and clicking on the bracket here and pressing delete. You can also instead right click. So actually, instead of right clicking, you can click on this star, and then you can copy, or what I recommend is convert it to an image, and that way you can actually paste it into Microsoft Word, or you can actually download it as a PNG. Okay, and that way you can have actually access to the output. So I'll give you a couple of other examples. On my own website, actually, over here under let's see, differential equations, resources, and differential equations with Mathematica, actually should be under projects with Mathematica. Actually, you should see the algebra with Mathematica resources and the working with functions. So I'm just going to go through a couple of these ideas now for you. Okay, so so most of arithmetic works as you would expect. So for example, fractions work as you would expect them to work. It treats them normally as fractions. If you want it to be numerically evaluated, then instead of doing 2/3, you want to do 2.0/3, and that way it assumes that you want it in decimal form. Alternatively, what you could do is you could use the n command. All commands in Mathematica are capitalized, and they take input inside brackets, not parentheses. This is important, these brackets. And you would just enter the fraction, or in this case, you could just simply enter the fourth output. So you could say n, I want the numerical approximation of the fourth output, and it will evaluate it. You can also specify how many digits you would like the fourth output. So let's say we want it accurate to 30 digits. It'll give it to us. In this case, we have a repeating decimal, so that was not necessary. We do have built-in constants like pi and the Euler constant E. All constants in Mathematica are capitalized. We can actually get the approximation for E up to, let's say, 50 digits by simply entering that command. So we can do algebra with Mathematica. Algebra works in the way you would expect. So this is 2x minus 3x squared. We could enter that using the Shift-6 command. So this is just basically adding like terms, as you can see. We can also factor algebraic expressions like x squared plus 3x plus 2. We can go backwards. We can take an algebraic expression and we can expand it. Okay. We can use the simplify command to evaluate algebraic expressions. And we can also perform partial function decomposition. So here is an example. So we can evaluate expressions at specific values. So let's say I have an expression like 2x plus 3, and I want to plug in the value x to be, let's say, 5. So what I use is I use the /dot command, and then I type x, and then the way I enter this arrow is I put the dash. I press dash, which is next to the 0 key, and then I use the more than symbol, which looks like this, except that when I enter them next to each other, Mathematica automatically turns it into an arrow. So /dot is basically the command for evaluation. It basically tells Mathematica that we want to plug in a value, and then the way we plug in value is we say x arrow 5. So it's going to basically plug in 5 into the expression, as you can see. If we have multiple variables, like for example, 2x plus 3 minus y, we can plug in multiple variables by using curly braces, and the rest is as you would expect. So here we have plugged in the number 5 in for x and the number 1 for y. So it has evaluated this. So we can define functions in Mathematica by using f of x underscore bracket colon equal sign. This looks a little bit complicated, but this is basically a way of specifying that we are defining a function with the independent variable x. All of these little symbols are important in order for this to work. So let's say we have the function x squared plus 1, something simple. We can evaluate numbers. We can do multiple evaluations, so function composition. We can take the derivative of that function, right? We can take that function and add numbers, or take that function and square it, and do all sorts of other algebraic and manipulations that you would expect. Okay. We can also, of course, graph it by using the plot feature. All we have to do is specify the function we want to graph, and then inside curly braces, we enter the variable of integration, the variable of plotting, so the independent variable, and then the domain. So let's say we want to go from -5 to 5, and here we have the the graph. Notice again, the command is capitalized. All commands start with a capital letter. Notice the brackets. I'm not allowed to use curly braces or parentheses. I am specifying two arguments here, okay, separated by a comma. The first one is the function I'm graphing. The second one, in curly braces, I'm specifying the independent variable along which I'm going to be plotting, and then the domain of that variable. Now, plot itself does have other features, of course, all options, so to speak. If you're interested in learning more about it, of course, you can just simply do a search for plot, and you will learn all about the different ways in which you can use this function. So here you can have some examples in which you can basically copy by simply clicking on it over here and then clicking here and Control V for pasting, and then Shift Enter to evaluate it. And of course, you can change parameters if you want. Notice the sign function, very important, is capitalized with an S. If you put a lowercase s, Mathematica will think that that is a variable. So all lowercase things, expressions, words, letters are considered variables for Mathematica. If they are constant, then they should be capitalized entirely. If they are functions, then they should start with a capital letter. So in this case, we have graphed the sine function from 0 to 7 pi. You could see that plot does have a whole lot of different kinds of features that you can learn about, and a whole lot of applications and options. So for the purposes of particularly calculus, we can do a whole lot of things with functions. So I already gave you the example of a function composition. We can, of course, evaluate functions. I already mentioned, I'm just plugging in. We can evaluate like so with the /dot option. And we could ask for the function domain with respect to x, of course. So in this case, this means that the function is defined for all real numbers. We can ask for the function range. You can see the function ranges, the y values must be larger than 1, as we expect. So we can actually solve equations as well. So the way we do that is we use the solve command. So let's do something simple, like 2x minus 1 equals 3. So you just enter the equation, but you have to remember to use two equal signs to specify that this is a this equal sign does not represent an assignment, but rather it is like a test, a logical test, like a logical connective. So it's not going to be assigning 3 to 2x minus 1, but rather is going to ask whether 2x minus 1 equals 3 temporarily, and it's going to find the value of x for which 2x minus 1 equals 3. And the solution shows up in what is known as a list. Notice that instead of saying x equals 2, it says x is assigned to 2. So this is kind of like the same assignment that you see here. So there's a lot to learn about lists, but one of them is that you can access whatever is in the list by using brackets. So for example, if I have a list of items like 2, 3, and 5, I can access. So let's say I have list is equal to 2, 3, 5. Let me actually name it. And then I want, let's say, the first item on that list. So the way I do that is double brackets 1, and it gives you the first item on that list. Let's say I want the third item on that list. I use double brackets 3. So now, as you can see, this here is actually a list. If I want the first item on that list, I can say, okay, give me the list, which is the 31st output, and give me the first item on that list. Well, the first item is actually a list as well. So it's actually a nested list. So to do that, I'm going to have, so this itself is a list. Since it's a list, I can access its first value by, of course, doing another double bracket 1, and that way I get the actual item in the nested list. So why am I telling you this? Well, because this is actually kind of useful in case we have a solution and we want to plug in this solution into some other expression. So for example, I could say solution is equal to, and then I can solve an equation. So let's say I'm doing something simple. How about sine of x is equal to half, right? For x. So we already know that one of the solutions is that, well, it's multiple solutions. So let's actually restrict this by specifying that x is between 0 and, let's say, pi over 2. So that should restrict our solution to pi over 6. Notice that I have entered this inside curly braces. So instead of entering one equation, since I'm entering an inequality, so to speak, to restrict my solutions, I had to enter this in curly braces. Okay, so now what we have this, let's say I want to take this pi over 6 and plug it into some other expression I have, right? So let's say I have an expression like x plus 3, and I want to plug in pi over 6 for x. Well, this right here is already a evaluator, right? It'll evaluate x at pi over 6. It'll plug it in. So I don't have to actually type x arrow pi over 6 because this already is. So all I have to do is say solution, okay? And then it'll actually plug it in. Now, in order for me to not end up in, this expression in curly braces, I could just do this. And now I have pi over 6 plugged into this expression. Okay, so these are kind of the tricks that we can play with Mathematica. Notice again the way in which the equal sign was used here versus here. So over here we have an equation, whereas here we have an assignment. We're saying whatever comes out of the output of this command, which is the solutions to this equation under this restriction, assign it to SOLN. Assign it to the variable called SOLN. So by the way, SOLN is always accessible. I already know what the solution is. I can always recall it, okay? Because I have assigned this to whatever is the output of that. So very useful kind of feature that will come in handy. Solve, by the way, can handle simultaneous equations. So I can also enter just 2 equations and 2 unknowns, as you would expect. And I just need to specify that I'm solving for 2 variables instead of 1. So I put that in curly braces as well. And here are the solutions, 7/5 and 3/5. Once again, if I need the numerical approximation, I just need to use the numerical approximator function, and it'll convert that for me. Now, for the purposes of calculus, we already talked about this. We can take the derivative of functions. but we can do a lot more than that. Before I go on, it's important to note that if we have defined functions over here, I have defined the function f of x. Well, f is now busy because it represents a specific expression, right? So in order for me to work with f, sometimes what I could do is I could clear it. If I do this, then if I call what f of x is, it's going to say, well, it's empty, there's nothing. So this is a way for us to clear variables to make sure that they're not busy equaling something else. All right, so once we have this, it's just a little bit about derivative. So let's say we have f of x is equal to sine of x. Let's do sine of 2x for good measure. So I already mentioned that this is one way to take derivative. And in fact, we can use double apostrophe signs to do second derivative. But what if we want to do fifth derivative? Well, if we instead we're going to use the d function. So the way you do this is you say, if you want to do the first derivative, you just do the derivative of f with respect to x, and you just enter it that way. But if you want to take the second derivative, what you do is you again enter f of x, and now instead of just x, you put in curly braces that you want to take the derivative with respect to x, and then let's say you want to take the fifth derivative, you enter the 5, and that way you get the fifth derivative of f of x with respect to x. So that's how you would go ahead and do that. Okay. As far as differential equations are concerned, so we will primarily use the dsolve command. So if we have a differential equation, let's say y prime of x, okay, is equal to y of x, the typical differential equation. Okay, we want to specify that the dependent variable is y and the independent variable is x. So that way we will get the function. So it tells us that the solution is a function, as you can see. And the function is e to the x multiplied by the arbitrary constant. That's what C1 is. This C1, by the way, is accessible like so, right? So that's how you would type this C1. It's actually technically a list stored in a constant called C. Okay, so if we wanted to plug in a specific constant here, we could. We just take the 50-second output and we say, okay, we want to plug in for C1, we want that to be, let's say, 5. And so now what happens is this function becomes 5 times e to the x. So this again is a function which technically we can use by evaluating it. Okay, but we already know what that is as well, because it's just 5 times e to the x. Okay, so that concludes the basics of differential equations, introduction, as well as for calculus and algebra using Mathematica.